Good morning, students. Today we will discuss about the electronic configuration of elements and the periodic table. As we all know that to express the position of an electron in an atom, we require four set of quantum numbers. The first quantum number that we call as a principal quantum number, which is denoted by L. Define the main energy level, which is known as a cell. And azimuthal quantum number represent the subcells. That is L. L indicates the subcell. So these subcells are also called as orbitals. As we already know that if L equal to 0, then we have s orbitals. If L equal to 1, then we have p orbitals. If L equal to 2, d. If 3, f. If 4, g. Like this one, it will go on. So these are the subcells or orbitals, we can say, of an atom. The distribution of electron in the orbital of an atom, the distributions of electron in the orbitals of an atom is called as an electronic configuration. So electronic configuration is nothing distribution of electrons in the orbitals. Then we call as an electronic configuration. And elements location in the periodic table refer the quantum number of the last orbital field. So the positions of an electrons or the positions of an atom in the periodic table is mainly due to the quantum numbers of which the last orbital field. Suppose if it is of 2s, then means we have the position in the second period and group is on the s group. That is, we have s calculated 2 electrons, so s1 or s2 we have. So if it is 1, then the group is of first, within the first group. If it is of 2, then the group is of second group. So like this one, the last orbitals in which the electron field indicates the position of your elements in the periodic table. Now let us see about electronic configurations in period. Now we will see about the electronic configurations in period. Electronic configuration in period. Now we will see this one first. Electronic configuration in period. The periods indicates the value of n for the outermost or balance. So period was indicated by the value of n for the outermost cell. So in another word, we can say that successive period in the periodic table is associated with the filling of the next higher principal quantum number or next higher principal energy level, we can say. So it can be readily seen that the number of elements in each period is twice the number of the atomic orbitals. So the number of elements in each period is twice the number of the atomic orbitals available in the energy level. that is being filled. Suppose first period, that means if n equal to 1. So if n equal to 1, then we have L value, L become 1 minus 1, that means what? 0. 0 means the orbital become S. So we have 1s only. We have 1s only. In the 1s orbitals, we have two elements. That is, one having the electronic configuration 1s1, and the one having the electronic configuration 1s2. As I already told that S can accommodate only 2 electrons. P can accommodate 6 electrons. D can accommodate 10 electrons. F can accommodate 14 electrons. Therefore, this one we have 1s1 and a 1s2. That is, 1s1 is of hydrogen and 1s2 is of helium. By putting 2 electrons in the first cell, that is K cell is completed. And then when we comes to L equal to 2, L become 0 and 1, that is S and P. So we have 2S and 2P. That means the electronic configuration is of 2s1, 2s2 and 2px1, or you can say then 2px2 you may have like this one. So like this one we need to fill up, say 2py1, again it is 3 electrons. So like this one 2pz1. So after that we may have 2px2, 2py2 and 2pz2. That means altogether we may have 6 electrons here and we may have 2 electrons here. So the total number of electrons which can accommodate in L cell equal to 8 electrons. So that means we have here, by putting 8 electrons, your L cell become completed. So like this, the second period, that is N equal to 2 stars from lithium, and the third electron enter into its orbital, and the next element, that is beryllium, have 4 electrons. Hence it will have 1s2 and 2s2. Starting from the next element, that is boron, the 2p orbitals are filled, and thereby the 8 elements are in such a way that in the second period, that is 2s2 and 2p 6 electronic configuration. Like this one in the third series, that means in the third period. So n equal to 3. So L become now 0, 1 and 2. That means we have S, we have P, we have D here. So as we know that S can accommodate 2 electrons. So the electronic configuration which is here is 3s2 and 3p6 and 3d. But while going from 3 according to your Abu's principles, the energy level, so we have S like this one. So you need to go here, that is on 4s. So we have that S like this one in the Abu's principle energy level. So the third pH will accommodate only 8 electrons, although it will have up to d orbitals, 3d, but 3d fill up later after filling the higher orbital, that is 4s2. S, 3p and 4s will have same value of n plus n value. So if there is the same two orbitals have same value of n plus n value, then those which have lower value of n, that is 3p, will have lower value, thereby the electron enter in the lower value first. So after filling this, the third RH will be ended, because before filling this 3D we need to go up to 4s. So 3D third period will have, that is your M cell. Actually M cell will have 18 electrons. So but out of that 18, up to we have 3p, that is only 8 elements are there in the third period. So here what we know that first period will accommodate only 2 electrons, and second period accommodate 8 electrons, third period accommodated 8 elements. So like this one, different number of elements are accommodated in different periods. So if you take n equal to 4, that is 4 period, let us see how much elements are possible in 4 periods. So in order to know that one, we have 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f. Then we have 6s, 6p, 6d, 7s, 7p. So according to Abbas principle, as we know that these numbers which is in one line will have same value of n plus l. So here we have taken n equal to 4. So n become now 0, 1, 2, 3. That means S, P, D, F. That is why we have written up to 4f. So if we have seen S can accommodate 2 electrons, P can accommodate 6 electrons, D can accommodate 10 electrons, F can accommodate 14 electrons. So when you apply 2n square, as we do know that 4 square, that means 32 electrons is possible to enter in this 4 cell. That is K, L, M, M cell. In the M cell, there is a possibility of entering 32 electrons. So now let us see to how much electron will be accommodated and how much element will be there in the 4 period. So in order to fill up this one, 4 period means we need to go up to this one, 4s2. Then we need to go up to 3d. That is what? D can accommodate 10 electrons and P can accommodate 6 electrons. After that, you need to go to the higher orbital, that is 5s. So it accommodated only these 3 substances. That is what? 4s2, 3d, 10, and 4p, 6. So there should be 18 elements. There should be 18 elements. That means 4p will have 18 elements. So in your periodic table, like this one, we need to fill up the elements in the periodic table in a period. But now here those electrons in which, or those elements in which the last electron enter in 3D belongs to 3D series. And if the last electron enter in P, then it is called as a P block. If the last electron enter in S, then it is called as a S block elements. If the last electron enter in P, then it is called as a P block elements. And if the last electron enter in D, then it is called as a D block elements. And if it is the F, then it is called as a F block elements. So in the periodic table which you have here, in the periodic table, the left hand side, this is left hand side, is of S block, and this right hand side is of P block, and in between the S and P we have D here, and F block will be written down the periodic table. The first one is 4F and another one is 5F. Like this one, you need to fill up the elements in the periodic table. So S block has two groups. That is group 1 and the group 2. After that, it is D block. D means 10 again. So this is D1, D2, D3, D4, D5, D6, D7, D8, D9, D10. So this D1 is called as a third group, D2 is called as a fourth group, D3 is called as a fifth group, and D4 is called as a sixth, then D5 is called as a 7, and then 8, then 9, then 10, then 11, then 12. After going to 12, P have, this is what? P1. This is P1. P1 is 13. So P2 is group 14. And P3 is group 15. P4 is 16. P5 is 17. And P6 is of 18 group. So like this one you fill up. So those which the last electron enter in S1 or the having electronic configuration S1 is called as a alkali metal. Alkali metal. And which have S2 is called as a alkaline earth metal. Alkaline earth metal. And this D1 to D10 is called as a transition elements. Transition elements. As they are the intermediate between S and the P block. They are intermediate between S and the P block. So they are called as a transition elements. If the electrons enter in 3D, then it is called as a 3D transition elements. If it is in 4D, then it is called as a 4D transition elements. If it is in 5D, then it is called as a 5D transition elements. If it is in 6D, it is called as a 6D transition elements. Like this one. So we have transition elements. And after that, those in which the last electron enter in F, there are the parts in which the last electron enter in 4F, that we call as a lanthanide series. If the last electron enter in your 5F orbital, then it is called as a actinide series. Actinide series. So both altogether lanthanide and actinide series are also called as inner transition elements. Now we will see how to find out pairs or groups in the periodic table by using electronic configurations. Now let us take an elements having atomic number, say we have atomic number 46, that is palladium, PD. palladium, atom number 46. Now let us try to write the electronic configuration. 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d, 7s, 7p. Now, same value of n plus n value we have already calculated. Now, we need to fill up that 1s, that is 2 electrons. Next is 2s, that is 2 electrons. Now next is 2p, have 6 electrons. After 2p we need to go to 3s, 2, 3p we have 6. Then we have 3d, but here we need to fill up 4s first, so 4s2. So you need to count it how many electrons was already filled up. 2, 4, 10, then 20 electrons. So 46 plus 16 electrons remains, so 10 we can add it. So 3d 10. Then we, after 3d, then we need to go to 4p. Then we have 10, 20, 30, and 20, 30. 30 means this is 36. This is 36. After 4p, we need to go to 5s. So we have 5s2. So 36, 38. Then after 5s, we need to go to 4d. So 4d, how many electrons remains? You need to calculate it. Now we have 10, 20, 30, 38. So only 8 electrons remains. So you have 4d8. So according to this, now the last electron entered in 4d. So first let us try to find out period. Period means highest value of n. Highest value of n is the period. So here n value means this 1, 2, all these are called as n value. So here the highest value is 5. So this element belongs to fifth period. So it belongs to fifth period. So again, that we need to find out groups. In the groups, it is of D group. That is, it is in 4D transition series. It is in 4D transition series because the last electron is in D. So for the D, you need to do it as here also you can see it. This is D, D1, D2, D3, D4, D5, D6, D7, D8. That is on 10. It is on 10. So we have group 10. It is in the group 10. So PD will have fifth period. This is on fifth period, and group is 10 group. In group 10. So in short, we can say that for the groups, if it is in S, that means last electron in S orbital, then OR is the group. OR is the group. Now, if it is in, then if the last electron is in P orbitals, then P orbital, then you need to add that 12 plus last electron is the group. Suppose if it is of P1 means 12 plus 1, 13, group 13 is the group of that elements, like this one. So again, if it is of if it is of d orbitals. Then means last electron is in d orbital. Then 2 plus last electron. 2 plus last electron is the group. Now, if it is on f orbitals, then we write, for f in the first series and 5f in the second series. So like this one, we need to write it. So always remember that the group is in 3. Group 3. So this and what are in group 3. So like this one. This is the rules how to find out your pair or group by using electronic configuration. So you need to recall this one properly, and then we will see it about the group wise your electronic configuration. Say according to Abbo's principle, the electronic configuration of an atom provides the theoretical foundation of the periodic classification. The elements in a vertical column of the periodic table constitute a group or family. So for the P block we say family. That is why we call here also family. And exhibit similar chemical behavior. That means those elements which is in same group possess same properties. That is what it was there. The similarities arises. That means the similarities in the properties arises because of the elements have the same number and same distributions of electron in their outermost orbital. That means because of similarities in electronic configuration, they possess similar properties. So we can classify the elements into 4 blocks, which I already discussed. That means first one is S block, second one is P block, third one is D block, and F1 is F block. Then in the S block we have 2 elements, as I already told. One is group 1, that is your alkali metal, which have S1 electronic configuration, NS1, you can say NS1. So whereas the one which have NS2 electronic configurations are generally called as alkaline earth metal. So this is what about the S block. So S block elements, let us see. S block elements, I have already told that there is 2, one is NS1, another one is NS2. NS1 and NS2 are called as S block elements. They are all reactive metals. These S block elements metals are of reactive metal having low ionization enthalpy. That means all these elements will possess low ionization enthalpy. Because of that, they are highly reactive metal. And generally, they lost their outermost electron and they are ready to form +1 or +2 ions. Mostly, your alkaline metal form +1 ions, unipositive ions, and alkaline earth metal form dipositive ions. The metallic character and reactivity increase. The metallic character and the reactivity increase as we go down the group. That means when you move down the group, in either group 1 or group 2, the properties having metal will gradually increases. And this is because of high reactivity, they never found in the purest form. That means they are always found in nature as a compound but not in the purest form. That means they are not non-reactive metals. They are not non-reactive metals. And the compound of the S group elements, with exception to those of lithium and beryllium, are generally predominant in ionic character. That means generally the compound formed by group 1 and group 2 elements except lithium and beryllium are almost ionic. Only lithium and the beryllium form covalent compounds. This is what you need to recall it. Now we'll go to the P block elements. P block elements consisting of group 13 to group 18, as we have already seen it here. Group 13 to group 18. So these elements are called as representative elements or main group elements. P block elements are generally called as representative elements or main group elements. The outermost electronic configuration varies from, that means the outermost electronic configuration of almost all the P block elements is of NS2, NP1 to NS2, NP6. This is the outermost electronic configuration of your P block elements. And all the orbitals in the valence shell of the noble gas are completely filled. That means orbitals of group 18 elements are completely filled by the electrons, and hence it is very difficult to alter this stable arrangement by addition or removal of electrons. That means they are stable, group 18 elements are stable. Because of that, it is very difficult to add an electron or to remove an electron from this compound, from these elements. Noble gases thus exhibit very low chemical reactivity. So group 18 elements are almost having low chemical reactivity. So yes, you already know that this level side, which includes metal, that is your S block elements, are highly reactive, and among the P block group 18 elements are least in reactive, very least in reactive among the all elements. So then group 17 elements, group 18 elements are generally called, I have already told that group 18 elements are generally called noble gases, and then group 17 elements are called as a halogen. That means salt forming, halo means salt forming elements. As most of these elements in the group 17 combine with the metal to form a salt, because of that they are called as a halogen. And group 16 elements are called as a chalcogen. These two elements, that means group 17 and group 16, are highly negative electron gain enthalpy, and readily added one electron or two electron to attain the stable noble gas electronic configuration, and they are almost non-metallic character, and the non-metallic character increase when we move from left to right across the palette, and metallic character increase as we go down the group. That means if you move from left to right, then we have non-metallic character increases. But when you move down the group, metallic character increase, non-metallic character decrease. And this is what about the P block elements. For today, up to this only we will discuss. Thank you.